Welcome to the Software People Stories. I'm Shiv.
I'm Chitra,
And I'm Gayatri.
We bring you interesting, untold stories of people.
associated with the creation
Or consumption of software-based solutions.
You'll hear stories of what worked.
and sometimes what didn't,
You will also hear very personal experiences.
and insights that would trigger your thoughts.
And inspire you to do even greater things.
My guest today is Mike Bowers, Chief Architect at FairCom. We had a very interesting conversation that we decided to publish this in two parts. In the first part of the conversation, Mike shares his career path and his perspective on how to approach software development. He emphasizes the importance of understanding the customer needs and designing systems that are flexible and scalable. We also talk about his passion for music and the importance of data in software development and his experience of working with different data models. All that and more in this first part. For part two, I asked him about aspects associated with handling unstructured data, and we also talked about the qualities of a good architect. All that and more in the second part. Listen on. Hi, Mike. Welcome to the Software People Stories.
I'm glad to be here. Thank you.
Like we always do, we'll start with a self-introduction. I'm curious about how you got into IT and what has been your career trajectory, and we will take it from there.
Okay. Well, I started when I was 14 and I started programming. I got an old, at the time it's brand new, but it's a Atari ST computer. And no, it was a TI-49A. Sorry, my next one was the Atari ST. Anyway, I started programming then and just have had a passion for programming ever since. I worked professionally in the 80s, programming software as a consultant, building all kinds of systems. I built a show management system for conferences so that a vendor could go into a conference and manage their entire show, print out the ID badges, let people scan the badges and all that. And that was back in 1986. And then worked my way through college programming, but I majored in college in music. So my passion at the time was music. I was a piano performance major, then a music composition major, then a music theorist. I got my PhD, ABD in music theory. So I like to think in those abstract terms. And just as a side note, I recently found out from my 23andMe test that I have a high aptitude in rhythm, and they say I have the highest aptitude that they record in playing an instrument. And they said, you must play an instrument. I go, yeah, well, I do. I thought, well, there it is. It's in my genes, And I've been thinking all throughout my 40 years plus of programming about why do I love music so much, and why does that make me a good programmer? And a lot of it is patterns. And so when because it is about patterns. You see the patterns in the music. I see the patterns in the programming, in the object-oriented programming, and so it's really fun to. I just love to find patterns and use patterns. And so I wrote a book, CSS and HTML design patterns, and it's all about the patterns in CSS and HTML that you can leverage in your code to accomplish what you can do in CSS and HTML. So I wrote that in 2007. So my whole career has been about patterns, and that's what led me to become an architect eventually, in the last 20 years of my career, because architecture is all about patterns, helping developers, designing things that follow patterns that developers can implement to solve solutions that are effective and useful for others.
Well, wonderful. I think there's a lot of questions, and particularly I've been fascinated by this analogy of software development, or particularly learning software and learning music. We'll probably come to that in a little bit. But before that, when you said that you were always interested in abstraction and patterns and so on, when you're creating solutions and when you're working with people who probably describe, I want this to be done like this, or or they say that, yeah, I don't know, maybe, this is okay. And either there is ambiguity or there is very, very precise expectation saying this is what should be done. Uh, how do you think as an architect to even abstract it?
Yeah. So first, I really try to put myself in the shoes of the customer, and try to understand what does the customer really want. Sometimes when you're, well, not sometimes, most often when your employer says, I want to do X, um, your the employer's vague. They don't really quite know exactly what they want. They just know, hey, I want to sell more of this, or I want to achieve this, or this customer is asking about that. And then so I put myself in the shoes of the customer using my years of experience too. And the more experience you have, the better, because then you can more effectively put yourself in their shoes and ask, what would I want as a customer? That's, and if I can't do that, then I'm probably in the wrong job um, because I can't really relate and I can't design well. But if I can do that, which I've been lucky in my career to do that all throughout, then I could say, how would I want this to look? How would I want it to work? And then from there, I could take and use myself as a guinea pig. And then I talk to other people and make sure I have a broad enough perspective to find out what the requirements really are, not what somebody told me they are. Because what people tell you and what the requirements really should be are two different things often, not always. Because customers will tell you if you interview them, they'll tell you what they want, but they don't know how to articulate in technical terms. And often what they want is not what they need. And so you really have to see behind the curtain, and find out what do they really need, what are they trying to do, and then you design. And I like to work with the data first. I found that as a programmer, I can just code it. I can just build a solution. I've done that before. But if I can look at the data underneath that we're trying to collect, that we're trying to use, and I design that well, then the application flows so much easier. Um, and so I've spent my entire career from very early days looking at data first and code second, which is a little different than a lot of other developers. They often do code first and data is an afterthought. Hey, give me some bit bucket. I'll throw the data over there somewhere, uh, which is probably why I ended up being the chief architect at FairCom as a database company designing the next generation of databases, because I care a lot about how you store data, how you retrieve, how you process data in more efficient ways and make it easier for the developer to do their job. And that's why my previous job, I was the data architect for the Church of Jesus Christ of Latter-day Saints, which is a large multi-billion-dollar organization, international, and we had thousands of developers. And I was in charge of making sure all the database technologies that were in use and all of our standards and practices. And I even ran their Oracle team, their SQL Server team, their NoSQL teams, and we brought in NoSQL databases. The whole goal was to make life effective for all those engineers in it. And that's why data has been such a passion of mine for especially the last 20 years of my career. But my heart in the beginning and still to this day is a software developer. That's where I just love coding and implementing. It's just I evolved into becoming an architect is what happened.
Yeah, wonderful. In fact, takes me back a memory lane when we used to study data structures and algorithms first,
Yeah.
right?
Yes,
Look, the
yes.
classic book. Yeah, yeah, that's true. Nowadays, it's all about, can I write something code, then ship something out, and then they'll figure out. But abstraction also, I guess, is at a data level where if you can model the different objects that you need and how they are likely to interact, I think it makes it a lot easier and flexible, to create code that will give you the required views and so on. So a couple of
Yeah.
related things is, when you said that you get some specific requirements or sometimes the users are not clear, how do you factor in the need that might change or grow over time?
Oh, I love that. That's huge for me. Now, part of it's because my personality is more of a strategist than a tactician. So I'm always looking out. In fact, people just joke and I've said, Mike, you live 5 years in the future. You got to get my current boss always says, there's now next and future. And Mike, you're living in the future. I got to build stuff now, so I always am looking forward. But here's a real life example. Recently, we're building an IoT platform at FairCom using our database engine, combining it with connectors to these IoT protocols like Modbus and Siemens S7 and Ether, Allen Bradley PLC protocols, all these protocols. And one of the core ones is MQTT. So we have a built-in MQTT broker. It's a whole development platform and also an end user platform where the users in the factory can go and configure and say, I collect data from this device and point and click, and it gathers the data. Well, that's the goal, to get to the end user. We built the whole back end to do it, but now we got to build the user interface. And we're looking at just unlimited numbers of connectors. There's several hundred protocols in this space for pulling in. We pull in all these protocols. We collect data from all these devices a lot of them are really old. They've been around forever, but factories keep their hardware around for a very long time. And they should, because it costs money. And why? If it's working, why break it? So we need to connect to all those things. And the problem with the user interface is if you build a one-off user interface for every protocol, and you have hundreds of those, and then you go and change some part of your architecture, you have to go back through several hundred of those and change them all. So I'm looking forward to the future going, well, this is going to be unmaintainable if I have my UI engineers hand code every one of those interfaces. They're going to go crazy with tedious, boring work. It'll take forever to get upgrades done. So I thought through, how can we solve this problem? And the answer is to use a pattern I discovered about 20 years ago. Actually a little longer than that. I was in my PhD course. I took a in my PhD program. I took a course in artificial intelligence, and in that course we were using Scheme. And I learned the pattern of, if code is data and data is code, if they're the same thing, then you can get to the term is isomorphism, but that's just some Greek word. The point is they're the same thing. And if your data is code and your code is data, you can write the code to change the data, but that data is code. Now the code is changed. That means code can rewrite itself. That was the whole premise. So I took this pattern and I found if you can use JSON as your data, and then you write a declarative language in JSON that declares what you want it to do. Then your JSON's also code. So you have declarative code and declarative data. And so with that pattern, I started using that in everything I do. And it's an amazing, wonderful pattern. It speeds up everything. What you end up doing is defining these little declarative languages that are like configuration languages, or I want this to happen. And you just say in the JSON, you configure, okay, I want this to happen with these parameters, sort of like a function call. And then you pass that into the engine, and the engine will run an interpreter, which could be like written in JavaScript or Python or Java or C# or whatever language you like. And it reads the JSON and says, oh, you want me to do this. And then it interprets it. It does the work. So some people call this configuration-driven programming or data-driven programming. So I took this pattern and said, let's build a user interface language that you define the forms in JSON. Now, this is nothing really new. Microsoft has a whole framework that does Silverlight, that does XML and creates forms using XML as the same pattern. So this is not totally brand new for me. It's just a really good pattern. So I used JSON, defined a forms language in JSON. I'm working with our front-end engineers to do that. They implemented it, and I showed them some tricks on how to implement it quickly, because you could, in JavaScript and JSON, you could do things very fast. So we built the driver that can read these configuration files, generate the forms, and allow us to edit all these configurations for controlling our drivers that collect data from these machines. And by the way, the machines are configured using JSON. So everything is JSON in our product. Even our database is JSON. Our query language is JSON. Everything's JSON. So now you get this beautiful symmetry around everything you do is configuring JSON, and you create these layers of JSON. So now our UI guys can go in minutes, and that's not an exaggeration, in minutes configure a brand new input from a machine and configure that machine and collect its data, create a whole user interface in minutes. And then later, we found, and so that worked great. And then we looked at recently, I was going through it and I go, I don't like the way this is working. So we actually revised the user interface. Instead of having to rewrite all these forms, all I had to do is say, okay, let's tweak the user interface to work this way. So he changed his code, the one who wrote that part of the interface, and if in just a few days of work, hundreds of connectors can be updated like that.
I don't know if you ever had a chance to work with, I would like to call the system, not a language, but Smalltalk.
Yes,
Yeah.
yeah, I
So,
just a
which
little
is,
bit. Yeah,
yeah, well, the same concept. No? It's data and code, kind of they can learn and grow and change and become a lot more proficient. So coming back to the abstraction and the scaling and looking at the future and so on, the two common challenges, the patterns of challenges that I've seen or people come to are one is they call this a project mindset versus a product mindset or a platform mindset when you create something. Uh, so as an architect, which side do you tend towards? Maybe that's a obvious question. But the second part is how do you communicate this to the development team? Because you are
yeah.
thinking at a certain level, and then if you need to translate that into actually working code.
Well, I do think in the platform, and I like to, I'm strategic, so I like to build long-term platforms that give you wins over time. Um, and it takes a lot of experience to do that. So if you don't have years or even decades of experience, don't do what I'm about to say because you won't have the experience to build a platform. It takes years of programming to know how to build a platform that's not throwing away a lot of work. Because if you build a platform and you're not ready to do it, if you don't have the experience to do it right or close enough, you'll build a platform and then it won't work, and then the people are unhappy. So what I'm about to say is really more of a senior pattern where you've got a lot of years of experience, and then you can build the platform and get some productivity. But you have to be forward thinking because the platform is always futuristic. That's why a lot of companies don't do that today. A lot of companies will be project focused. They'll say, all I want is a form right now. Build me a form today. I know I can get it done in 3 days or a week or whatever it takes. And then you get it done, you ship it, and then you worry about long-term technical debt and maintenance later.
Mhm.
But because there's not very many seasoned architects around that can build good platforms. And so you have to know you have one of those guys in your team. And then when you do, like when I'm on the team and I do this, then the management has to trust the person. So it's also a risk. Like the owner of my company right now, I said I wanted to build this platform for quick user interface development. And he fought me for several weeks on this. Are you sure you can do this? Are you sure this will work? Because he had never seen that actually work in the past. And so he trusted me and he had it working. And now he's delighted. Now he's bragging all over the place. Oh, look at what we could do. And we could pop it out in minutes. So it's risky if you don't really know your stuff. Building platforms is risky. So that's where you have to you just have to know what you can achieve with the platform. But if you can do it, then communicating to the team depends on the level of skill they have. So I have one senior UI person who's been doing this as long as we have, and I was able to communicate with him in a few sessions of just verbally explaining
Mhm.
this to him, and he immediately got the idea, and then he started down the path, and we iterated. So he gave me back a schema in JSON that says, I want to create my UI schema to look like this. I had previously designed some for another company, which I couldn't share with my current company. I couldn't share the design because of, it's because of
Yeah.
agreements. But I couldn't like hand him the spec for this, but I let him create it because he wanted to. And then I reviewed it and said, yeah, well, let's tweak the JSON here, 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 and here, because that's going to cause you problems because I had already done this kind of work. And he tweaked it. He pushed back for a little while. I mean, I explained the reasoning, and then he tweaked it, and we did that a couple of times, and it's working beautifully now. So that's one example of a very senior person, and I can work with him verbally, but most of my engineers, I have to write it down. So what I do with them is I will create a document that shows it by example. I find that if I show things by example, engineers pick it up very quickly.
Mhm.
So rather than writing UML or abstract design docs, most engineers don't read that very well. But and since I chosen to work mostly with JSON, it's easy. I just create JSON documents that describe the functionality I want them to build. So I say this is the document that defines what, for example, we have JSON language for our database that could create tables and create insert records, create indexes, read records. So I would create JSON and say, if you want to create a table, here is the JSON to create the table. Then I would write documentation on it, the end user documentation, showing, okay, here's what each property in the JSON is going to do. Here's the table name. That's kind of obvious. It's the name of the table. But you'd get more complex things like the array of fields that go in the table. What is the field length? What is the field type? And all those things. And I define all that out. And then the engineers take my quote unquote documentation for the user, and then they take it and interpret it, because that's the whole idea of this pattern is you interpret the JSON, they implement the interpreter for it. Then they bring it back to my team. I have a QA team, and they go and test it based on my document. And then I go and test it too once it gets thoroughly running and well, so I don't waste too much of my time. And then I go through it and make sure it works the way I like it. And through that, so basically by writing the developer documentation for the JSON schema and having that to the engineers, they're able to implement it. But these are senior engineers. So I can't just verbally say, hey, go do this, and they do it, but I can give them the spec by example and by documentation, and then they go implement. And that's turned out to be really effective. Yeah, but then I have some junior engineers on my team, and that's not good enough for them. And those guys, I have to train them. I have to meet with them. I show them the docs, and it's a lot of personal interaction to train them and teach them these patterns, because they don't have any concept of the pattern. So it varies by your audience, I guess, is a short answer. What level I have to do.
That seems to be very practical way of doing it. So what about the aspects of performance? Since you talked about abstraction and also the interpretive style of coding or designs.
Oh yeah, I'm a performance nut, so that came really early on in my career, which fits well with the database company, because it's all about how fast can you process data, and that's one reason why I came to work for FairCom, because we have an incredibly fast data processing engine, and all of developers are developer nuts. So we recently built. Over the last several years, but we're releasing our brand new version of our MQTT broker, which is built into our Edge platform, our IoT platform. And it's an industry standard MQTT broker. So there's a couple things that differentiate it from others. It has everything that you publish to it. So it's a message queuing platform. So you publish messages to it, and it delivers messages to subscribers. And you publicly publish messages to a topic, and then the topic, anyone can subscribe to the topics. So you don't know who the publishers are, you don't know who the subscribers are, just you're publishing and subscribing to topics. It's an industry standard, so when you're competing with the others, there are other brokers on the market. Performance is important, and also key differentiators could also be, in our case, we store every message, so we guarantee delivery. We never lose a message because we store it in our internal database, and then you could query it in our database. So those are some core differentiators, but the performance, to your question, is really important, because everyone who wants to buy an MQTT broker says, well, how fast can you go? So I've spent a ton of time with one of our Q engineers to really performance test it. And I had to train him on how to do performance testing and the difference between performance testing and load testing, which are a little bit different. Load testing is you push it to the limit till you break it to see where it breaks under load. And performance testing is what level of performance can you achieve continuously forever? But there's very similar kind of testing. And so I trained him on I wrote a document to define all the testing I wanted done, and all the variations of like, how many publishers are publishing at the same time? How many subscribers are subscribing at the same time? What are the size of the messages? What are the frequency of the publications? That kind of stuff. To find all that out in a bunch of scenarios, gave it to him, and he's writing tests in Python to implement all those scenarios to see how our broker behaves under different conditions to make sure it'll handle our customer use cases.
So since you are into databases, this is one question I have to ask about handling unstructured data.
We thank Siddharth for the music and Anita for promoting the Software People stories.
If you like this episode,
Please subscribe on your favorite podcast client.
And spread the word in your network.
if you'd like to share your story,
Contact us at podcasts@pm-powerconsulting.com.